Hello, amazing students. We are going to go over a little bit of the lesson on 10.1.1 so we can check some answers and also make sure that we understand some of the important stuff coming from association and two-way tables. Remember, we went over things such as Venn diagrams and also a little bit about two-way tables, and we're going to see which ones we prefer. First of all, remember, data is often collected in categories. Categorical data can include your gender, what classes you're taking, eye color, hair color, height, income, weight, number of hours in exercise in a week, what brand of hair, whether you prefer cats, whether you have a job, whether it's a vegetable or a fruit. All of these things that can be done with a survey or by collecting data are things that you can put into, you can categorize. And as you categorize things, you can decide whether you want to categorize your data with a Venn diagram or more something like a two-way table or a table. Now, there's certain things we do have to kind of keep in mind is, remember, there are multiple types of ways to organize your data, but one of the most common ways people use is when comparing two things, event A and event B, we use a Venn diagram. Now, we have to remember as well that it's possible to have an event where it's only A, which is right here, only sunny, for example, only rainy, which is event B, and then there's two more possibilities. The possibility where it's, for example, sunny and rainy. Have you seen that before? And the last one is when it's not sunny or rainy. So there are four possibilities to keep in mind. Let's flip our page. All right, problem 10-1, I asked you to solve this, and now we're going to check our answers and make sure that we understand it, because this is a little tricky, and we want to make sure we can understand it. So first of all, Martha Vandeloo, amazing individual right there, is conducting a survey for the school newspaper. She surveyed 175 students, okay, that's good, at her school, and found out that 28 students had a new Pi phone. We'll put the number 28 here. 44 students had a laptop computer. 44. And 110 students had neither. Okay, let me put that in a different color here. 110 students had neither. Remember, neither is not in the inside where it's both. Neither is where they don't have a Pi phone and they do not have a computer. Now, I did make somewhat of a mistake so far. It says to use the information to put it into the Venn diagrams. Here's the mistake that I think I can say I made. Now, remember this 44, these are the number of people that have computers, right? These are the number of people that have computers. Now, that doesn't mean they don't have a Pi phone. They could be over here. Some of them could be here. So I guess I could put the number 44 up above just to kind of make a note that some of those people have a computer only, which is this region over here. But some of those 44 also have a Pi phone, which they'll be over here. So we have to be a little bit careful about this problem and see if we can solve it. So there's something special that you might have done, and if you did this, this is great. There are 175 students, right? How many students? 175. What do you think this adds up to? If you added it up, you would have seen something special. Let's check it out. What is 28 plus 44 plus 110? What is 28 plus 44 plus 110?
It's 182.
So we get 182, but there are only 175 students. So if I subtract these two numbers, I will get how many of those people have both. 182 minus 175.
It's 7.
That means there's 7 of those people. Remember, 7 of those 44 have a Pi phone, meaning only 37 have just a computer. Okay, so again, 44 is the number of people that have a computer. 28 is the number of people that have a Pi phone. But if 7 people have both, then we have to subtract it. What's 28 minus 7? That one's a lot easier. We're going to get the final answers of 21. So you might notice a Venn diagram is not always the best way to figure out categories and number of people, but there is a way to do it, and it involves a lot of subtraction. So it says in question B, how did you determine the number of students who had both Pi phones and laptops? You can say, I added 28 plus 44 plus 110, and I got 182. Then I did 182 minus 175 students, because that's how many people that were surveyed, and I got 7. That is the number of people that had both. Question C, how many students have Pi phones or laptops? How did you find this? So according to our diagram, if we did it correctly, all we need to do is do 21 plus 7 plus 37. These three numbers, this is the number of people that have either a Pi phone or a computer. Let's add those up. 21 plus 7 plus 37.
It's 65.
We get 65. Alternatively, we could have done 28 plus 44, but I need to subtract 7. The reason why is because 7 people have the computer, also 7 people have the Pi phone, and I don't want to count them twice. So I will subtract what we call the intersection. If I do that correctly, guess what we're going to get? 28.
Sorry, I don't understand.
28 plus 44 minus 7.
It's 65.
We also get 65. Question D. Recall that 28 students had the new Pi phone and 44 students had a laptop. Why can't you just add 28 and 44 to get the answer in part C? Explain. So again, just like Siri, I don't understand. If you don't understand, this is a part that we need to make sure we understand. It's why can we not just add 28 and 44? It's because it counts the number 7 twice. And 7 is the number of people, or students in this case, who have both. Remember, 7 is part of the 44. That's why we subtracted. And 7 is also part of the 28. So that's why we subtracted. So let's go ahead and flip our paper. We're going to move on to the next page, which is the more important part, where it says we can organize all of this data into a table. 10-2. Really Bay said he could not figure out how to put the data from problem 10-1 into a Venn diagram because it was what? Yeah, it was hard to find the number of students with both iPhones and laptops. So he put the information into a table like the one below. Now let's look at the table first of all. Let's see if it all makes sense. 175 is the total, the grand total number of students. And the total is always on the bottom right corner. Next up, we need to see that there's also rows, which go horizontally, and columns that go vertically. And the columns, if there's a number at the bottom, that's because that's the number of people that have a laptop. For the rows, if it's at the end, that's because that's the number of people that have a PiPhone. And you'll see there's some missing numbers. Also, you'll notice that these tables have a yes to PiPhone and a no to PiPhone, which you can see right there. A yes to laptop and a no to laptop, so it covers all possibilities. And you could figure out whether a person has a PiPhone and a laptop, or even just a laptop with no PiPhone. So it does take some time to get to understand these two-way tables, which it's called a two-way table. But it's one of the best ways to organize our data because it includes all possibilities. All right, so question A says complete Rayleigh's table to figure out the number of students in the missing cells. So remember, totals are called totals for a reason. It's because if you add up two things, it will equal the total. So what's the opposite of adding? Yeah, we can figure out this missing piece by subtraction. Let's do that subtraction. 175 minus 44.
It's 131.
We get 131. Now we can figure out this one by subtraction as well. Remember, these two numbers right here add up to 131. 131 minus 110.
It's 21.
131 minus 110 is 21. You see, as we figure out all the missing pieces, you can figure out, well, all the missing pieces just by doing subtraction. 175 minus 28.
The answer is 147.
147 goes here. You see, as you figure out more, you can figure out the remaining pieces. Now these two right here add up to what? What do those two add up to? You see how the arrow that points to 147? This row, that's the number of people that have no PiPhone. 147 minus 110.
The answer is 37.
So we get 37 here. And then for the last piece, we can figure that out just by doing subtraction this way or subtraction this way. Now, which one looks a little easier to you? Probably this way, horizontally. What number plus 21 equals 28? Of course, it's 7. So 7 plus 21 equals 28. We can confirm we did it correctly. 7 plus 37 is?
It's 44.
Yeah, so everything will add up correctly. And if you really want to make sure you did this correctly, all four of these numbers should add up to what? What do you think? Let's see. 7 plus 21 plus 37 plus 110.
It's 175.
So we know that we did it correctly. Again, adding all of the inside numbers will give you the grand total. Adding the rows gives us the side totals, and adding the columns gives us the bottom numbers. Okay, so this type of way to organize the data is called a two-way table, and it's often used to organize information and calculate probabilities. That's important. Probabilities is the chance, the likelihood, the odds. Why do you think it's called a two-way table? How is the two-way table similar to and different from a Venn diagram? So you can put your own answer there. I think it's called a two-way table because it it covers the yes and the no for everything, and it involves two different events or variables. Two events. And what's the main difference between a two-way table and a Venn diagram like this one right here? Yeah. The main difference is that it includes all possibilities it's with a yes or no, with a yes-no style. A yes or no organization. All right, let's see what question C is. We're going to do 3 probabilities, and I'm going to have you do the remaining problems here. Actually, I'm going to do 10-3 as well, just to check our answer for 10-3. All right, it says, if we assume that Ms. Vandeloo surveys from a random sample of students in her school, okay, random just means it's by chance you randomly chose somebody. What is the probability that a student at her high school has an iPhone or a laptop? All right, iPhone or a laptop. Now this is pretty key. iPhone or a laptop. Let's highlight it. These are the number of people that have a iPhone. And these are the number of people that have a laptop. If you added the totals, you don't want to count what? You don't want to count 7 twice. So if you add up these totals, make sure that you don't count 7 twice. So one of the best ways we can do this is just by adding up the 3 numbers here. 7 plus 21 plus 37. Oopsie. 7 plus 21 plus 37.
That would be 65.
We get 65 out of 175 students. Oh, I need to simplify that. So I will take my calculator, 65 out of 175. I'll press the math button and press enter to change it to another fraction, a simplified fraction, which is 13 over 35. Or you can just go ahead and do your answer as a decimal. So the answer as a decimal happens to be approximately 30, let's see, 0.37. Let's do two more decimal places. 3714, which is 37.14%. Okay. What's the probability? Question number 2. What's the probability that a student has a iPhone? Okay, how many people have a iPhone? Look at the numbers here. How many people have a iPhone? Yes to iPhone. You're going to look at the end, which says 28. Or do 7 plus 21. So iPhone, there's 28 people that have a iPhone. So 28 out of the total number of students, which is 28 out of 175. So again, I'll use the trick here. 28 divided by 175. Press the math button. Change that to a simplified fraction, and we get 4 over 25, which I know is 0.16. And all of these answers are good. Just remember, if you're going to write your answer as a fraction, you have to simplify. So if I divided both numbers by 7, I would get this simplified fraction. Alternatively, I just use my graphing calculator to simplify. Okay, last question before we move on to 10-3. What's the probability that a student has a iPhone and a laptop? All right, let's see. From our table, again, this is why the table is so good, because it tells us all the possibilities. How many people have a iPhone and a laptop? 7. Let's write that down. There are 7 people who have both a iPhone and a laptop, which, remember, we figured it out over here as well. There are 7 out of how many people? Yeah, 7 out of 175. So the random chance of choosing somebody out of the 175 people who has both a PiPhone and a laptop is 7 out of 175. Now, I know 7 is a prime number, so I'm just going to do 175 divided by 7 to see if it goes in. It does. So I'm going to go ahead and get an answer of, well, let's just do it a different way. 7 divided by 125. Enter. 0.056. Or 7 divided by 175. Math fraction gives us a simplified fraction of 1 over 25. Now, just for this one, we're going to change it to a percent as well. Remember, a decimal is always good. They're great answers. But if you do want to change it to a percent, just move the decimal over 2 places, and we'll get 5.6%. Okay, whatever your test says to write it as, write it like that. If it's a fraction, simplify it. If it's a decimal, write it down. And if it's a percent, just move the decimal over 2 places. All right, last problem that I'm going to go over. You're going to do 10-4, 10-6, and try this one on the bottom as well. But before we do that, we want to answer question 10-3. This is something that's going to prepare you mainly for integrated math 2. Is there an association between owning a laptop and owning a PiPhone? Does owning a laptop affect the people that have a PiPhone, or the choice of having a PiPhone? Let's see. That's called an association. Are they related? In other words, if you own a laptop, are you more likely to own a PiPhone? Oh, that's a great way to put it. Investigate this question by calculating the probability that a laptop owner owns a PiPhone. Then compare that to the probability of a non-laptop owner owning a PiPhone. So the first probability we're going to do is laptop owner owns a PiPhone. How many people that are laptop owners own a PiPhone? Oh, this is super tricky. There are 7. Yes, there are 7. But it's only out of the people that have a laptop. How many people have a laptop? 7 out of what? 175? No, that's not the number of people that have a laptop. 7 out of 44. So a bit tricky here. That's why I'm helping you out with this one. And the second one we're going to compare that to is the probability of a non-laptop owner owning a PiPhone. So how many people are non-laptop owners? The non-laptop owners are right here. How many of them are there? Total is 131. I'm going to write that down. 131. And how many of those non-laptop owners own a PiPhone? Let's see. 21. 21 out of 131. So what it asks us to do is compare this fraction to this fraction and see if it's more likely for a laptop owner to own a PiPhone. Let's see. These are the laptop owners. And these are the non-laptop owners. So let's see the fractions. Just as a decimal, 7 divided by 44 is 0.1591, just by rounding it. And then for the non-laptop owners, we get 0.1603. So is it more more likely? It says, is it more likely for a laptop owner to own a iPhone? The answer is no. The odds of having a laptop and a iPhone, or a laptop owner owning a iPhone, is a little bit lower than those who don't have a laptop. All right, so what I'm going to have you do today is work on problem number 10-4. Basically finish the packet here. 10-4, 10-6, solve the problem at the bottom to the best of your ability. And if you want some extra practice, this one on the back is very good. So 10-8, I'll consider this one optional for today, but the other ones, go ahead and complete that right now.